Okay, so today we are going to talk about section 4.3, which is the graph of a rational function. Today's learning target is going to be, I can use the 7-step method to graph a rational function. And so before we jump into these examples, I have 4 examples for us today. I want to list out what those 7 steps are so we can just follow them step by step, one at a time, to understand what it is that we're trying to do. So step 1, I want you to factor the numerator, and once again, in regards to 4.2, we're still going to refer to the numerator as n of x, and we're going to refer to the denominator as d of x, where numerator is the polynomial function that's on the top, and the denominator is the polynomial function that's on the bottom. There's a second piece to step 1, which we're going to find the y int. I'll say find and plot the y int. And very simply, the y int can be found at f of 0, where I evaluate my function at f of 0, and that would give me the value where it crosses the y-axis. Okay? Step 2 is going to be write the function, and I'm going to refer to this as r of x, which is going to be the rational function, in lowest terms. I'm going to put this in quotes because we normally talk about lowest terms as fractions, but we do think of this rational function as a fraction, which is a polynomial over a polynomial. And after you do this, we're going to set the numerator, which is going to be n of x, equal to 0, because that's going to give us our x-intercepts. So the y-intercepts are going to relate to finding the function evaluated at 0, and the x-intercept is going to be where I find just the numerator and set that equal to 0, to find and plot the x-intercepts and their behaviors. Normally we talk about if it's going to cross or touch the x-intercept, above and below the x-axis, and so on. Step 3, we are going to find the vertical asymptotes, and what you remember from section 4-2, in order to find the vertical asymptotes, we set the denominator equal to 0. Done that lots of times. Step 4, we are going to use the degree test, which we also talked about in section 4.2, to find the horizontal asymptotes. And in the case of the degree test, we could also find if there's a slant asymptote, if the degree on the top is 1 more than the bottom. So these kind of go together. You can't have both. You can have just a horizontal or a slant. Step 5 is a possibility if you need additional test points in order to graph this thing. I will say that you'll choose the easiest questions or the easiest points on here that would give you some information about how the graph is curved and what points it's going to follow. I'm going to say find additional test points. And there are some easy ones that you can choose. Normally we choose 0 if it's not there. Oh wait, we already chose 0 in step 1. We can choose 1, 2, -1, and -2 are real easy numbers that you can pick in order to find some additional test points that you need. Step 6, we are going to find the behaviors near the asymptote. So what happens as values get very, very large? What happens as values get very, very small? And what happens as values get very, very close to where the asymptote is? And then finally, step 7 is to put everything together and to graph the function r of x. So step 6, find the behaviors near the asymptote. We'll do that. And then step 7, graph your function r of x. Let's start out with an example. Graph paper will be very helpful for you. I don't have any, so I'm just going to give my list over here online paper, and that's fine. I'm going to give you a function. In this case, r of x is equal to x minus 1 over x minus 2. So we have our rational function that looks like this, and we'll just list out the steps 1 through 7. The first thing for step 1 says to factor the numerator and the denominator. They're already factored. They're just little binomials, so there's nothing to factor here. But we do have to find the y int and plot that, and the y int is where my function is evaluated at 0. If I take 0 and plug it in, that's -1 on the top and -2 on the bottom. So really that's -1 over -2, which I'm going to plot as 1/2. So let me make a grid over here on the right-hand side, and we'll go ahead and plot this 1, 2, 3 in each direction. So 0, 1/2 is going to be found right here. So I know my graph is going to cross that point on the y-axis. Step number 2, write the rational function in lowest terms, which it already is in lowest terms. I'll show you ones that aren't here in a little bit. Set the numerator, my numerator is x minus 1, equal to 0 to find the x-intercepts. The reason that the numerator gives you the x-intercepts is because if I have 0 on the top, that makes everything 0. So I have an x-intercept at positive 1. So we're going to go ahead and plot that right there. Step 3, let's find the vertical asymptotes by setting the denominator x minus 2 equal to 0. In this case, I have a vertical asymptote at positive 2. We notate all of our asymptotes on rational functions with dotted lines. So I'm just going to put a vertical dotted line through positive 2, which is going to look something like this. Step 4, use the degree test to find the horizontal or slant asymptote. I look at my degrees. This is a 1. This is a 1. The degrees are the same. When the degrees of the top and the bottom are equal, you have a horizontal asymptote at leading coefficient over leading coefficient. The number out in the front is a 1 over a 1. So 1 over a 1 is 1. And so I have a horizontal asymptote through y equals positive 1. It's going to look something like this. Now, we don't have any other points to find. We got the y-intercept. We have the x-intercept. So we're going to plot a couple of additional ones to see if this can help us graph. I think I know what this shape is going to be sort of on the lower left section of where these intercepts intersect, or these asymptotes intersect. I'm going to plot f of negative 1 just to make sure that I kind of know that this is going in the right direction. So if I plot f of negative 1, this is going to be negative 1 minus 1, which is a negative 2 on the top, and negative 1 minus 2, which is a negative 3 on the bottom. So that's going to be a positive 2/3. So negative 1 up 2/3 is going to be like this. It looks to me like this is going to cross through here and come down and get closer and closer and closer to that asymptote like this. And it's going to come over here and get closer and closer to that horizontal asymptote like this. Think about it. If I plug in a negatively very large number like negative 1,000, that's going to give me negative 1,001 on the top and negative 1,002 on the bottom, which is very, very close to positive 1. So you can see the behavior near the asymptote there. And that really is us kind of working out step 6. There's one more additional test point in step 5 that I want to find. I already have 0. I have plus and minus 1. 2 is going to be undefined because there's an asymptote there. But 3 would help me determine where that other branch is going to go. Sometimes we call these branches. If I take 3 and plug it in, that's 3 minus 1 is 2 on the top. 3 minus 2 is 1 on the bottom, so that's a 2. So 3 comma 2 is going to be a point that I can plot right there. And if you want to go a little bit further, you can plot f of 4 and see what might happen. 4 minus 1 is 3. 4 minus 2 is 2. So this is going to be 3/2. So right to 4 and up 1.5, which is going to be right here. I can assume that this is going to get closer and closer to the asymptote in this direction and closer in that vertical direction as well. So that's what this is going to look like. Got the behaviors near the asymptotes. 7, I've graphed all of R, and that's what it's going to be. So that's the step-by-step process. Let's do a couple more that are a little bit more difficult. Example 2. My function r of x is going to be x plus 2 on the top and x squared minus 9 on the bottom. So let's follow our step-by-step process. Number 1, let's factor the top and the bottom and then find the y int. The top is already factored. The bottom needs to be factored. So let me write this as x plus 2 over. This is a difference of 2 squares, which is a dots question. So I can factor it like this. X squared is going to be x times x. And when I have a minus 9, I can do an x plus 3 and an x minus 3. And I can go ahead and think about foiling this out to figure out, is that what I'm going to get on the bottom? Yes, it is. And then we can evaluate my function at 0 to figure out where the y-intercept is going to be. Take 0 and plug it into the top, that's a 2. And into the bottom is a negative 9. So the y-intercept is going to be at negative 2/9. So go ahead and plot this right over here. I'm going to go 4 in each direction. And my y-intercept is going to be just below the origin. Negative 2/9 is very close to negative 0, or 0 from the negative side. Step 2, let us write it in lowest terms. If I had an x plus 2 on the top and an x plus 2 on the bottom, I could cancel those out, and that would be lowest terms. The factors have to be the same. We'll see that soon. But then again, we can set the top equal to 0 to find the x-intercept. So it looks like I have an x-intercept at negative 2. So we're going to go ahead and graph that negative 2, which is going to be right here. Okay. Step 3, let's find the vertical asymptotes. My vertical asymptotes are going to be found where the denominator, which I'm going to write already in factored form, is going to be set equal to 0. I have two factors that are equal to 0, which means I should have vertical asymptotes at +3 and -3. Let's go ahead and plot those. We have two vertical asymptotes in this problem, and that is widely accepted. It's going to happen from time to time. Step 4, let's find a horizontal asymptote. My horizontal asymptote, I'm going to use the degree test. The degree on the top is 1. The degree on the top is 2. Since the degree on the top is 1, the degree on the bottom is 2. Since the degree on the bottom is larger, that's going to grow faster, which means I'm going to have a larger number on the bottom, which I remember as going to 0. So that's going to be y equals 0. I will have a horizontal asymptote directly on the axis. Find additional test points. So we need a few other test points to help us graph this thing. Maybe 1 would be good, so let's evaluate f of 1. We'll do that in a second. 2 would also be good, so we'll evaluate f of 2. Notice that just kind of gives me points that's in the middle. These points that are in between -3 and +3, f of 4 and f of -4 would help me determine where this is going to be on this side, and I can sort of think about those branches. Let's evaluate. If I plug 1 into the original, that's going to be 3 over -8. So let's call that -3/8. That's going to be 4 over -5. It's going to be 6 over, call that 6/7. Bottom, so let's call that -2/7. That might give us the information that we need. 1 comma -3/8 is going to be over 1 down almost to a half, not quite. 2 comma -4/5 is going to be almost to -1, not quite. 4 6/7, we're going to be right 4 and up to almost 1. -4, -2/7 would be sort of in that direction. So I kind of see what's going to happen here. If I think about numbers that are very, very close to 3, like 2.9, if I take 2.9 and plug it into the original, right, this is going to give me, we'll say 4.9 on the top, and then 2.9 squared minus 9 is just going to be a very, very small negative number, right? And then a small negative number on the bottom is going to be a large negative number. So I think that this is going to come down, cross through the x-axis, hit my test points, and this is going to jump down on the negative side like this. Okay? I can also assume that this is going to come down here, and as x gets large, is going to get very, very close to the horizontal asymptote in that direction as well, right? And kind of think about if I plug in a very large number, say 1,000,000. On the top, I have 1,000,002. On the bottom, I have 1,000,000 squared, which is what, 1 trillion, minus 9. So very close to 1 trillion. So that's 1,000,000 over 1 trillion, which is very close to 0, and it's on the positive side, so it looks like this. So 6, I have the behaviors near the asymptote, and 7, I graph the whole thing. A couple more examples here. Here's a different type. My rational function is going to be x squared minus 4 on the top and just x on the bottom. It says factor both. Now it looks to me like I could factor the top as a difference of 2 squares, which is going to be x plus 2 and x minus 2. And it looks like the bottom is going to be just factored on its own. So we also want to find f of 0 to find the x-intercept, the y-intercept. And if I take 0 and plug it in, wait a minute, I have an x on the bottom, so there is no y-intercept. So let's get some more information about this. Step 2. I want to find the, I'll write it in lowest terms, so it already is in lowest terms, nothing that we can cancel here. But I want to set the top, which I already have factored, as x plus 2, x minus 2 equal to 0, to find the x-intercepts. So my x-intercepts are going to be found at 2 and -2. So we can go ahead and plot these points. So there's -2, there's +2. Step 3, we are going to find the vertical asymptotes, which is found by setting the bottom equal to 0. Well, I just have an x on the bottom. So let's go ahead and just say x equals 0. So I have a vertical asymptote, which is going to be directly on top of my axis. If you want to put your dotted line when it's on top of the axis just a little bit off to the side, or a little bit darker, you can kind of see where that thing is going to be. Step 4 is going to be a horizontal asymptote. Well, the degree on the top is 2. The degree on the bottom is 1. So for a horizontal asymptote, there is not a horizontal asymptote because the top is going to grow much faster. But I do have a slant in this case. My slant is going to be found where I long divide the bottom into the top. Remember, we're going to have to annex a 0 for the linear term because I have a missing term there. The first term goes into the first term x times. The reason being because x times x is x squared. You want those to be the same. When I subtract that away, I have nothing. I can bring this down, I have nothing, and I bring down the minus 4. X does not go into negative 4 at all, so the negative 4 is my remainder. So we're going to write this as x minus 4 over x. This remainder, as x gets very, very, very large, is going to disappear. And so the x is all that I have left for my slant is going to be y equals x. So you think about graphing y equals x as a linear function. The b value is 0, which I can plot there. Remember, this is part of my asymptote. So when I plot my asymptote, my b value is 0. The slope of y equals x is 1. So I can go up 1, right 1, up 1, right 1. And that kind of gives me the points that I need in order to graph the slant asymptote, which is going to look something like this. Okay? So I have a vertical asymptote through 0 and a slant asymptote through y equals x. Let's find some test points to see some more information about where this goes. I have my X-Intercepts, so those are good. I think 1 and -1 would be good points to find. Maybe 3 and -3 would also be good points to find too. So let's plot these into our original function. If I take 1 and plug it in, this is going to be 1 squared minus 4 divided by 1. So we can call that -3. By -1 is +3. Bottom, let's call that 5/3. 3 is going to be a -5/3. I think these points will be very useful for us. 1, -3 is going to plot down here. And then +3 5/3 over 3. 5/3 is what? 2 and a little bit more. So there's a 1, 2 and a little bit more. So it looks like I have these 3 points which go through like this. And it's going to approach my slant asymptote and my vertical asymptote like that. -1, 3 is really just the same thing, just on the negative side. And then -3, -5/3 is going to come down here like this. So I can go through my 3 points. 6, we have it close to the asymptotes, and 7, regraphed all of f. One last, my rational function is going to look like this. On the top, I have 2x squared minus x minus 3. And on the bottom, I have x squared minus 1. Let's do our steps. For step 1, says to factor the top and the bottom. Let's do that and see how this factors. I think that most of these are going to be very friendly, and you'll be able to factor these. I know the bottom I have x squared minus 1 is a difference of 2 squares. Let's call this x plus 1 and x minus 1. On the top, I have a 2x squared, so let's call this 2x times x. And I have a 3, which I'm going to use 3 and 1, and I want to get a 1 in the middle. So I can put my 3 here and my 1 there, because if I do outer, that's 2x, and inner, that's 3x, I can get my -1 that I need. The -3 says the signs are different, and the minus goes to the larger, so the minus is going to go here, and the positive is going to go there. Now, what I can do for step 1 also is to evaluate my function at 0. Sometimes it's easier to go back to the original, right, to evaluate 0, because all of these variable terms are just going to be disappeared. So on the top, I have -3. On the bottom, that's a 0, so that's gone. So that's just -1. So I have an intercept found at +3. Let's go ahead and graph this thing. Step 2, what is it that we have to do? Step 2 says to write my function in lowest terms. So in order to write this in lowest terms, notice I have these factors that are the same, and I am allowed to cross these out. I have 2x minus 3 on the top and an x minus 1 on the bottom. And it also says to find the x-intercept, I'm going to take the top, 2x minus 3, and set it equal to 0. If I add 3 and divide by 2 on both sides, it looks like I have an x-intercept at 3/2, which is also called 1.5. So there's 1, 2, 1.5 is going to be right there. Step 3, we're going to find the vertical asymptotes. I'm going to have the vertical asymptote. Remember to use the reduced function that we have. Set the denominator equal to 0. If x minus 1 equals 0, I have a vertical asymptote at +1. Step 4, let's use the degree test to find the horizontal asymptote. I have a 1 degree on the top and a 1 on the bottom. Since they are the same, it is found at leading coefficient over leading coefficient. which in this case is going to be 2 over 1, which is 2. So I have a horizontal asymptote through 2. Step 5. Let's plot some additional test points. Well, I got 0 plotted. I have 1, which is an asymptote. I got 1.5. 2 might be a good one to find, f of 2. Maybe 3 would be a good one to find if I just kind of continue out in that way. And then maybe -1 if I want to go on this side, and then also -2. If I'm going to sort of move in this direction, -1 and -2 would be good ones to find. If I take 2 and plug it in, that's 2 times 2 is 4 minus 3 is 1, and 2 minus 1 is 1, so 1 over 1 is 1. So I have over 2 up 1, which takes me right here. 3 times 2 is 6 minus 3 is 3. Over 3 minus 1 is 2, so that's going to be 3 over 2. Up 3.5, which is 1.5. Remember, I have that horizontal asymptote at 2, so it's just going to be below that. So it looks to me like I'm going to have these getting closer and closer to these asymptotes in that direction. So let's call that -5 over -2 on the bottom. That's -1 minus 1, which is going to be 5 halves. Think of -1 comma 5 halves as -1 comma 2.5. This is at 3, so let's go 2.5, which is here. I'll move that up a little bit. And then finally, -2 plugged in is going to be -4 minus 3 is -7, over -2 minus 1 is -3. Let's call that 7/3. So -2, 7/3 is about 2 1/3. So let's go, remember my horizontal asymptote is at 2. My 1/3 is just going to be a little bit more. And we're going to connect these with a branch that looks something like this to get closer and closer to that. Now, there's one additional thing that we need to note. In the original reducing, we had an x plus 1 that we crossed out of the bottom. Okay? And we actually evaluated -1 to be 5 halves. But if you take -1 and plug that into the original function that we have here, -1 squared is 1 minus 1 is 0. This actually gives you a 0 in the bottom. All right, so this 5 halves that we had is actually not real. That's going to be undefined at -1. I can use the 5 halves to graph the branch, which I did at -1 5 halves, which is here. But this is going to give you what's called a hole. So at -1, this is not in the domain, so I actually have to have an open circle listed right there. And in order for me to see these on your graph, if you could label those hole and then have an arrow pointing because you have a hole there because one of these canceled out of the bottom of the thing. All right, so we have all of our behavior near the intercepts, and we have the whole graph of our graph. And you can also type this into your calculator to give you some confirmation that you did everything correctly. So I hope this has been helpful for you. You know to find me in room 312 or on Remind or over email at jwilcox@davisonschools.org if you need any additional help. Thank you very much.